Good. So two approaches are completed, do good. But the question here, which one is the best? Which one is the best? So generally in the project level, where is extending thread class, we are frequently using, implementing runnable also frequently we are using. But which one is the best? Coming to the best, generally we are saying one point. Tell me, in the first approach to create a thread, what is the syntax? Tell me here. In the first approach to create a thread, your class myThread, your myThread class, it is always extends which class? Predefined thread class, right? Always extends predefined thread class. Then only your thread is created. Tell me here, your thread is always extending predefined thread class. One Java class is able to extend so many classes at a time here? Only one class, right? Multiple inheritance is not supported by Java. One Java class is able to extend so many classes at a time? Only one class. But in this case, I would like to acquire the properties from some A class. Tell me, in this case, it is possible to acquire the properties from any other class? No, because it is possible to extend so many classes, only one class, that is thread class is already done. This is the problem with first approach. What is the problem here? Whenever we are extending thread class, internally we get the control of our thread. So out of two approaches, in the first approach, when we extend a thread class, your thread is created, but in Java, one class is able to extend only one class at a time. It is not possible to extend some other classes. But what is the second approach? Tell me here. The class, here also my thread, here I am able to implement which interface here? Runnable. When we implement the runnable, it is possible to extend the A class or not? It is possible to extend A class, it is possible to acquire some properties or not? Good. So the reason everyone is saying which one? We are saying the second approach is best approach to create a thread. Because in the second approach, it is possible to extend some X class, it is possible to acquire some properties. But in the first approach, it is always extending thread class. In the first approach, it is always extending which class here? Thread class. It is not possible to extend any other classes, right? So there is information regarding what? Extending thread class, implementing runnable interface. So which one is the best approach here? The second approach is best approach. We are able to acquire the properties from some other classes also. So I done that example regarding my runnable also, right? So that is information regarding what? Your two approaches to create a thread. I hope clear. Good. So I will give the internal implementation regarding thread class and runnable interface. Total how many approaches are there? Two approaches, right? Extending thread class, implementing runnable. I will give the predefined implementation, so check it. The predefined implementations are nothing. The sample point. What is the sample point? You know. So generally, how the internal implementations are going on means. So interface runnable, the second approach to create a method. It contains only one method. Public abstract. The method name is called what? Run method. So generally, internally, class predefined thread class. The predefined thread class, it is implements predefined thread class. It is implements which interface here? Runnable interface. So the thread class is overriding run method. What is the thread class overriding run method? Public void thread class is overriding run method. Public void run method. Open brace, close brace. But it is providing what? Empty implementation. But it is providing empty implementation. So concentrate. This is internal implementation. Runnable contains run method. Thread class is providing empty implementation. You know first approach, right? I hope. In the first approach, I declared what? Class myThread. So class myThread extends thread class. Extends thread class. I said what? Override the run method. Override the run method, right? Yes or no? Override the run method means what? Here I override and run method. Public void override and run method. Public void run method. Here we are written logics, right? Logics of thread. We are written logics of thread. This is the internal implementation. So actually the run method is belongs to runnable. Run method is belongs to which class here? Runnable class, runnable interface. The thread is providing empty implementations. Then in class myThread, we are overriding that method, we are writing your logics. I said previously one point. What is that point here? If we are not overriding run method, the parent class run method will be executed. What is the parent class run method here? Thread class run method will be executed. The thread class run method, it is having which implementations here? Empty implementation, right? There is a reason it's generating no output. I said one example also I given, right? One example also I given. So this is the way. This is the just a predefined implementation. Clear? Good. This is two approaches to create a thread in Java. Now the next one here, I completed two approaches. Now I would like to link with these two approaches with the anonymous inner classes. We are having one class. Java supports inner classes concept, but Java is not supporting inner methods, right? I discussed that points already. If you want, can please check the inner classes concept. Just generally, to reduce the length of the code, we are using anonymous inner classes. To reduce the length of the code, we are using anonymous inner class. Now, I will link with this first approach and second approach. These two approaches, I will write the same program with the anonymous inner classes concept. The nameless inner class in Java is called what? Anonymous inner class, right? Before going to the next three examples, first of all, can please check the video of anonymous inner class, then start listening this video. Because if you don't know anonymous inner class, we are unable to understand this example. Point is clear? That's the reason I said one point. Before going to the next three examples, first of all, check the anonymous inner classes, then start this video. Clear? So I will write the same example. I will write the first approach and second approach, two approaches with anonymous inner classes concept. So you can please check it. The nameless inner class in Java is called the anonymous inner class. So generally tell me how to create the thread in Java. First approach, class myThread, it extends thread class. Then here we are overriding run method, right? The public void run method. Here we are writing logics. Then what is the second one here? I declared class thread demo. In the thread demo we declared main method. The main method here, public static void main. So to start the user defined threads, we must depends on main thread only, right? Good. So here we are writing the main logics, main thread logics, right? This is general scenario. This is application without anonymous inner class. In the same application, I will write with anonymous inner class. This is my application without anonymous inner class. I will write the same application with anonymous inner class. So class thread demo. So here I declared main method. What is the main method syntax here? Public static. Tell me, public static void main. Public static void main. Then I declared string array args. String array args, open brace, closure brace. Now concentrate in this one here. Directly I created object of thread class. So here I am not declaring any extra class. So here I declared class myThread extending thread class, right? Instead of that one, I declared anonymous inner class thread t1 equal to new thread of open brace, closure brace. Here put the semicolon. Here semicolon is semicolon. Don't think about the spell mistakes. So in the comment, one person is writing in YouTube comments, Ratan, we did spell mistake in so and so online. That is a comments. Anyway, sometimes it may be mistake. Semicolon is mandatory. Semicolon is mandatory. So think about the content. Clear? Semicolon is mandatory, optional here. The semicolon is obviously mandatory, right? Good. So now here, which method I would like to write the run method? Write the logics here, run method, right? Directly override the run method here. There is no extra class is required. So class myThread, to overcome that length of the code, to reduce the length of the code, so generally we are going through anonymous inner class. This is without anonymous inner class. Class myThread extend thread class. This is with an anonymous inner class. If you want one more thread, the system dot out dot println of, then this is my what? First thread, right? First thread I'm printing. In the same way, if you want to create one more thread, Ratan, can you please create a thread by using what? Just changing this is T2. Total how many threads here? 2 threads. Then start the thread. What to start the thread here? T1 dot start method, then T2 dot start method. This is called with anonymous inner class. Directly I'm creating object. But concentrate. Don't think when I create the thread T equal new thread. Thread T equal to, sorry, this is what? New thread, right? Thread class object. Directly I'm overriding run method. So internally when anonymous inner class is generated, the output will be printed. Now concentrate. In this example, code is compiled, code is executed. First thread and first thread. Let me change the data here. What is the data here? Second thread. So always to reduce the length of the code, we are using first thread, second thread. First to second, because if application contains more than one thread, thread execution decided by thread scheduler, expected output or unexpected output here, unexpected. Run to run output will be valid. Code is compiled, code is executed, first to second, first to second, second first. Obviously the output is valid. So that is the information about what? Your anonymous inner classes approach. So this example is important. This is example number how much? I think this is example number 15. Good. The next one is example number 16. This is example number 16. Example number 16, I will paste the entire example. This is without anonymous, this is with anonymous. You are able to understand, right? No problem. The example number 17. What is example number 17? You can simplify this code also. We can simplify this anonymous inner class code also. How to simplify this code means use the nameless object. What is the nameless object? You know, new thread directly dot, the method name is called what? Start. You can write like this also. In some project level, the maintenance level, sometimes you are observing this type of code. Don't feel heavy. This one is also possible. Directly start method. So use a named object, nameless object, right? Code is compiled, fine, code is executed, first to second, rather than that previous code output. Okay, if you are feeling like that, first thread, only one thread is there, right? So you can write the code like this also to reduce the length of the code. This is example number what? 17. Some small observation. Next example number what? 18. I forgot to discuss one example in first level, in the initial classes. What is the example? You know, I call t dot start, right? Assume application contains only one thread with anonymous inner class. Okay, is the anonymous inner class no problem? Normal approach no problem. Any approach no problem. Thread is ready. I started the thread, then thread is started. Now code is compiled, code is executed, first thread is printed, right? Thread is running. I called same thread twice. The first example, while discussing first example, I given this point. Actually I forgot to give this point. When we start the thread twice, so it is not possible to start the thread twice. When we start the thread twice, it generates an exception. The exception is called what? Illegal thread state exception. So when we start that, is it possible to start the same thread twice or not? In interview they are asking like that. When we start the same thread twice, it generates the exception. Which exception here? Illegal thread state exception. Clear? So by using anonymous inner classes, it is possible to reduce the length of the code. So it is not possible to start the thread twice. If you have to start the thread twice, it generates exception. Which exception here? Illegal thread state exception will be raised. Good. The next one here, the example number 19. So let me write, this is the first approach, anonymous inner classes. The second approach, anonymous inner class. Generally, what is the second approach to create a thread here? The class myRunnable, which implements which interface here? Runnable interface. Here override run method to write the logics. Public void run method. I overriding run method to write the logics, right? So here I am writing logics here. Override the run method to write the logics. I written logics here, right? Good. The next one is what? Class. Class generally written thread demo. Different possibilities. Here I declared main thread. What is the main thread syntax here? Public static void main. Then I declared string array args. Open brace, closure brace. Here we are writing logics of. Tell me logics of. Then I written main thread. Logics of main thread is also written here. Now control is. Anyway, this is the approach. You know that approach, right? How to create the object and all. But this one is not recommended for us. We require the anonymous inner class. The same code I will write anonymous inner class as constant, right? So what is the anonymous inner class here? Generally I declared threaded demo class. The threaded demo main method. What the main method syntax here? The public static void main. Then I declared string array args. Main method. Open brace, closure brace. This is the main method syntax. Now here there is no need of myRunnable internal class once again. Actually the last, can you please check the previous example? Anonymous inner class. I am not creating any my thread class. Directly I am creating object of thread class, right? I am overriding run method. The same way here directly can you please create the object of runnable. Ratan runnable is the tell me, generally you are saying runnable is what? Runnable is interface, right? Ratan, how you created object of interfaces? Here object of interface is not created. Internally one implementation class will be generated. For that implementation class that object is created. That is called anonymous inner class, the nameless inner class in Java. Runnable are equal new runnable. It doesn't mean we are creating object of runnable. It means we are creating internally one implementation class object will be created. Internally one implementation class object will be created. So runnable contains how many methods? Only one method. Can please override that run method to write the logic. Let me write the system.out.println. To understand this, we must depends on first one, anonymous inner classes concept. First try to understand anonymous inner class, then think about this approach. This is my first thread. In the same way, let me create the second one also. This is my R1, this is my R2. But you know the one point. By using runnable, we are unable to start the thread. To start the thread, we must depends on which one here. To start the thread, we must depends on which thread here. Thread class, right? Thread T equal to thread T1 equal to new thread of, here I passed what? R1. Then can you please start the thread by using T1.start method. T1.start method. So in the same way, the second thread also. What is the second thread here? So in the real time code, I will do the modifications. Can please try to observe that modifications. This is my R2. This is my T2. Once you know previous videos, examples, then you are able to understand this example easily. If you are not checking previous videos, if you are directly checking this video, means you are unable to understand even single point also. So directly runnable, we are unable to start a thread. In a runnable case, we must depends on thread class only. For the thread class, we must pass which object? That runnable object. Runnable object is what? R1. First thread. Here can you please write the second thread. Now code is compiled, fine. Code is executed. First thread and second thread. Second thread and first thread. Immediate output is changed, right? So first time first thread, second thread is printed. The second time onwards printing second thread, first thread. Okay, anyhow, output is valid or not, check like that, enough. But in the real time you can modify this code, you can add extra code also. What is extra? You can reduce the length of the code also. How to reduce means directly you can please create the object of new thread. For this one we are expecting what? Runnable object, right? Here runnable is not possible. Okay, I will reduce that code in the next example. I will give you separate example. That's good, that's good. I will give the next example to reduce the code. I hope this example is clear. Runnable are equal new runnable of runnable are equal new runnable of. Ratan, in this example, can you please give me the practical proof? Actually, anonymous inner class I given already the proof. Ratan, R1 object, whether runnable object only created, rather new runnable we use means runnable object only created. You are thinking like that. To use some clarity about your thinking, can please call one method, the system.out.println of, tell me, R1 dot, the method name is called what? Get class dot, the method name is called get name. If really runnable object is created, it returns runnable. If really runnable object is created, it gives what? Runnable only, right? But can please check it. Variable R1 is accessed within the inner class, need to be declared final. Yes, the anonymous inner class purpose is that one. I declared final. Code is compiled. Variable R might not have been initialized. Variable R1 might not have been initialized. So first of all we must declare that one is the final. Actually this concept is clearly I discussed. Runnable R1 equal to null. Already defined method. Good. Now do this one. Actually that variable must be defined. Actually don't think about this example. Can please concentration on last example. The final, that one is good. To check the just proof, cannot assign a value to final variable or so good, leave it. This one is not good. I will do this modification. My anonymous inner classes, can please check the anonymous inner classes. The anonymous inner class has a given clarity. This one is not good, leave it. Good. This one is good. Code is compiled, code is executed. This is our example. I did some modification, but it is not allowed because in this anonymous inner classes we are unable to do runnable with runnable. If you want clarity about that, how to get the class, can please check the anonymous inner class video. Control S. This is the way how to use the anonymous inner classes way. How to reduce the code by using anonymous inner class. This is example number how much? 19. Clear? This is the example with the anonymous inner classes. Example with the anonymous inner class. Let me give you one more example, last example regarding these two approaches, some clarity. Two approaches. What the first approach here? The class myThread. Class myThread, tell me, it extends what? Thread class. Then override the run method. Public void run method. Public void run method, right? This is my first approach to create a thread. What is the first approach here? The system.out.println. Then tell me within the double quotes. First approach. Create a thread. First approach, right? What is second approach to create a thread here? Class myRunnable. It implements which interface here? Runnable interface. Here also override the method. Which method must override here? Public void run method only. This is the second approach, right? Obviously. Now system.out.println of. System.out.println of. Now within the double quotes, this is the second approach to create a thread. First approach to create a thread and second approach to create a thread. Two approaches are there. Good. The class thread demo in the real time how the fellows are writing the code means public static void main string array args open brace closure brace. Now tell me in this case what is the output here. First of all, I would like to create the object of new my thread, right? Directly can create the object new tell me my thread dot, the method name is called what? Start. Enough. What is the second one here? So we must create the object of thread class only. First of all, new thread. For the thread class constructor we must pass what? My runnable object or not? My runnable object. So after passing my runnable object, then start method. So you can check the previous example once. In the previous example, when I discussed the second approach to create a thread, what is the second approach to create a thread element? This is the second approach, right? Where is the first example? This is the first example regarding second approach. In this approach, instead of these 3 lines of code, directly you can use what? Nameless object, new thread of, here you can pass what? New tell me new my runnable of dot, the method name is called what? Run method. You can pass like that, no problem at all. This is the first example regarding second approach, right? In the same way I use the same approach here, new thread of new my runnable dot start method. Code is compiled, fine, code is executed. First approach to create a thread and second approach. First approach, second approach, first approach, second approach. Then your application contains 2 threads. Then which thread is executed first decided by thread scheduler. Expected output, unexpected output here. Unexpected behavior, obviously unexpected output. So output is valid or not? Good. Now in this case, this is the example number, so the 20th example, right? Good. After now we discuss 20 examples regarding multi-threading. 20 examples regarding multi-threading, right? Good.